A warm welcome to everyone. I'm Sri Raksha, student of Sri Venkateshwar College of Engineering from the Department of Computer Science and Engineering. Well, in this video, I'm going to discuss about stacks in data structure. Let's see what are the contents I'm going to discuss are what is stack, introduction to stack, implementation of stack, operations in stack, that is full, push operation, is empty, pop operation, display operation. Next one is applications in stacks. Let's see what is stack. A stack is a non-primitive linear data structure. It is an ordered list in which the addition of new data and the deletion of already existing data item is done from only one end, that is known as the top of the stack. Stack is a data structure which works on the principle of last in, first out. This is the main criteria in stack. That is, the last element inserted will be the first element to be deleted. This is an example of last in, first out. In this stack, A is inserted from the top of the stack and B is inserted upon A. Here C and D. If you want to remove E from this stack, we have to remove from the top of the stack. Let's see one more example. A common real-time example of stack is arrangement of plates in marriage hall. New plates are pushed onto the top and popped off the top. You can see here any item will be removed from the top of this stack. If you want to place any item, we have to place on this top only. Next one is implementation of stack, that is using an array. Create. The create function can be implemented using one-dimensional array. You can see here a small program, that is hash define size is equal to 5. Here I have declared the stack size is equal to 5. Int s of size in top is equal to -1. Here the size, it is a symbolic constant, specifies the maximum number of elements can be inserted into the stack. S size, it is an array which holds the size of an element or which holds the elements to the stacks. Let's see operation on stacks. There are various operations in stack. The few operations are push operation, pop operation, overflow or is full operation, underflow or is empty operation, and display operation. Is full operation. It is an operation which checks for an overflow. Once the stack is full, it is not possible to insert any elements. Pushing an elements to completely filled stack is called as overflow. In order to perform a push operation, we need to check whether the stack is completely filled with elements or not. This is the main criteria for push operation. That is, we need to check whether the stack is completely filled with elements or not. Let's see an example for is full. If top is equal to size -1, that is stack size -1, we have to print the stack is full or overflow. Then we have to return. Next is push operation. Push means adding an element or inserting an element into a stack. Only one item is inserted at a time and the item has to be inserted only from the top. In this, elements are added to the stack, top of the stack. For empty stack, the value will be top is equal to -1. At each time of adding the elements, the value of the stack will be incremented by 1 in push operation. Here is a picture of push operation. The empty size, the value of the top is equal to -1. Top is equal to 0. We are inserting the first element from the top of the stack. And here top is equal to 1. We are inserting the second element. Top is equal to 2. We are inserting the third element. Top is equal to 4. We are inserting the fifth element. Here the stack size is equal to 5. Let's see, next one is empty. It checks for underflow operation. Before we delete an item from the stack, we must check before whether there are any elements in the stack. or the process of deleting an element from an empty stack is called as underflow. Let's see an example. If top is equal -1, here -1 indicates it is an empty stack. Print stack is empty or underflow, then return. Next one is pop operation. The elements are deleted from the top. At the time of the pop operation, the value of the pop is decremented by 1. You can see it is a full stack. Top is equal to 4. When we want to delete the elements from the stack, we have to delete from the top of the stack. Top is equal to D is equal to 3. We have deleted the first item. You can see here top is equal to D 0, deleting the fourth item. Top is equal to -1, it is an empty stack. Next one is display operation. Displays the elements of the stack operation is called as display operation, or it prints the contents of the stack. You will see a small program, void display, int is equal to I. I have taken I as an integer. If top is equal to -1, it is an empty stack. We have to print. Then printf, contents of the stacks are, we have to use one for loop for it. 4 is equal to, I is equal to 0. I is greater than or equal to 0. I minus minus printf percentage %d comma s of I. It is an array size of an stack. Next one is application of stacks. There are various applications in stack. The few applications are, first one is to convert an infix expression into postfix expression, to evaluate postfix expressions, to implement recursion, to reverse a string we use stack, to evaluate arithmetic expression, to check whether a string is palindrome or not, to store history data, for management of memory, backtracing algorithm, function call management. Thank you.